Jai Hind to all. My name is Divya Sharma. Now today's video lecture is on Stokes theorem. Now Stokes theorem states that the circulation of a vector field A around a closed path L is equal to the surface integral of the curl of A over the open surface S bounded by L, provided that A vector and delta cross A are continuous on S. S is a surface. Now this is the formula of Stokes theorem. LHS side is closed line integral A dot dl, and right hand side this is the integral with respect to surface del cross A, means curl of A dot ds. This is your surface S, and this line is a closed path that is represented as L, and take a small part of surface that is represented as ds, and take a small part of length that is represented as dl. Now prove the surface S, this is the surface, is represented as S subdivided into a large number of cells as shown in this figure. These are divided in large number of cells. If the kth cell has a surface area delta Sk and is bounded by path Lk, means this is a surface considered in the this is ds considered in S surface and divided into large number of cells, and it is represented as delta k Sk and path is represented as Lk. So in the interior part there is a cancellation on every interior path, so that the sum of the line integral around Lk's is the same as the line integral around the bounded curve L. Now you can see at the interior side, these are cancel out, these are also cancel out, here these are cancel out. So at the interior side you can see these are cancel out to each other. Now the left part is only the outer side. So this is the closed line path. So this is the closed line path. Now here left hand side, this is the closed line integral A dot dl is equal to summation k line integral that is represented when we are dividing it large number of cells, then that is represented as summation closed line integral, and it is represented as Lk A dot dl. Now here multiply in numerator and denominator by delta Sk. Now take the limit on right hand side of equation, that is delta Sk, that is tends to 0, and incorporating leads to this final equation, and this is Stokes theorem. Left hand side, this is closed line integral A dot dl, and on RHS right hand side curl of A dot ds, and here you have to take integral with respect to surface. So this is Stokes theorem. You should learn this equation while you are solving the questions. And this theorem is used to calculate circulation, means closed line integral of a vector field around a closed curve encircling surface. And the closed line must encircle a surface, so these points should be remembered while you are using Stokes theorem. And this is the equation of Stokes theorem. Above theorem is not a universal theorem, and above theorem is applicable if A vector is differentiable and continuous in surface encircled by C, which means A must not tend to infinite at any point in S encircled by C, means nothing should be in denominator or it should not be in form of tan. Then you can say that is also you can check for continuous and differentiable. Means here it should not, your vector, it should not tends to infinite. Now here left hand side, this is line integral a dot dl. You can check, you can solve it by using a dot dl. This is C1 line, a dot dl. This is C2 line, and so on. You can add all the lines, means closed line integral, or you can check, you can do it by using Stokes theorem. How we can start with the Stokes theorem? First we have to check, is it continuous or differentiable, or you can say a vector is analytic in S, then you can apply this Stokes theorem. And this is the right hand side of Stokes theorem. Means first you have to find out the curl of A, then multiply it by ds. This is inverse Stokes theorem. So this is the right hand side of Stokes theorem. First we have to find out curl of A, then that is multiplied by ds, and left hand side, this is the line integral of a dot dl. Now here if you are taking lines, means if you have a closed line integral, now you can represent it I, and you have to take here summation a dot dl. This is closed line integral, that is equal to outline a dot dl. Means let us consider this is an example. So interior part is cancel out, and the left part is this. This is your closed line integral. So here this is the outline, means you have to consider this line A. Let us consider this is A, B, C and D. So closed line integral, that is equal to what? AB plus A to B. Now second is B to C line integral plus C to D plus line integral D to A. So we can calculate it like this and add all these four, or you can find out it like this, curl of A dot ds. This is your right hand side. Okay, so this is the inverse Stokes theorem. Means in Stokes theorem, this is the left hand side and this is the right hand side. Here in inverse Stokes theorem, this is your left hand side and this one is your right hand side. Now let us take an example, that is f vector is equal to x square y unit vector of x minus y unit vector of y. The circulation of the vector field, that is represented as f around closed path as shown in below figure. Now here we can see this is x axis, this is y axis, this is origin. Now you have a line from this origin to 1 point and 1 point to 2, 0. Now find out the line integration, means find out the line, equation of line. For this equation of line from origin to 1, that is equal to y is equal to x, and this is 2, 0. So find out the line integral, that is equal to y is equal to minus x plus 2. Now here let us consider a part of this line, closed line integral. So you can represent it by a horizontal line, and this is denoted by S. Now here you have four options: A 7/3, B minus 7/6, C 7/6, and the fourth one is minus 7/3. Now you have to find out by using Stokes theorem, and you have to check the answer from these four options. Now here, so left hand means you have to apply here Stokes theorem. So left hand side of Stokes theorem is f dot dl, means closed line integral f dot dl is equal to right hand side del cross f, means this is the curl of f dot ds. So here first we have to apply, we have to find out curl of f. So given f is equal to what? X square y unit vector of x minus y unit vector of y. So how we can write down the curl of f? This is your unit vector of x, this is unit vector of y, this is unit vector of z. Now del upon del x, del upon del y, del upon del z. So it is in form of rectangular coordinate. So rectangular coordinates are represented in form of x, y, z. So here we have to represent it in form of x, y, z. First we have to write down the unit vector of x, y, z. Now here del upon del x, del upon del y, del upon del z. Now here write down the values from vector f. So vector f, from vector f, if you have a unit vector of x, means value of unit vector of x, write down here x square y, here minus y, here 0. Now find out the curl. How we can find out? Ax del upon del x. So left this part, this row and this column, and write down this part. So write down it like this. This is a matrix del upon del x, sorry, del upon del y, minus y, del upon del z, here 0. This is your first matrix. Now minus ay unit vector, write down here del upon del x, x square y, del upon del z, zero. So first we have to take positive sign for this for negative, this for positive. So write down here first, this is in form of positive, this is in form of negative. Now here positive a z unit vector in matrix, write down here del upon del x, x square y, del upon del y, minus y. Now solve these matrix and you will get here x square unit vector of in negative form unit vector of z. So this is the output of curl f while you are solving these matrices. And you should know, in cylindrical form dl is equal to dx unit vector of x plus dy unit vector of y plus dz unit vector of z. Now here put this value and this value here in this equation, Stokes theorem. How we can put all these values? First we should know ds. ds unit vector means you have to find out for z. Here is the unit vector of z. So find out ds is equal to what? Dx dy. And it is in negative form. How we can write down its direction? Now you can see this is in clockwise. So its direction is in this form. So it is in clockwise, and clockwise you have to take, and this one is x-axis, this one is y-axis. So write down unit vector in form of z, and it is in clockwise, so take it in negative form. So if unit vector is in z form, so this is in z form, so write down here dx into dy. So write down ds is equal to dx dy unit vector of z. Now here this is your curl of f, this is ds. So you should know the value of curl of f and ds. So put these values in this Stokes equation. So put these values here. Now find out, this is unit vector of z, this is unit vector of z. So write down here x square, it is in form of negative, this one is also in form of negative, so negative negative plus. So write down here x square dx dy. Now integrate it with respect to this. These are the limits of x, these are the limits of y from the figure. So here 0 to 1, and this one is x-axis for x-axis 0 to 1, and for y-axis y to 2 minus y. So y to 2 minus y. So write down the limits of x and y and find out this by using integration, and you will get the value 7 by 6. So this is the answer. Now let us take another example. A is equal to rho cos phi unit vector of phi plus sin phi unit vector of phi. Now evaluate closed line integral a dot dl around the path shown in figure and confirm this using Stokes theorem. So this is your figure. Now this is x-axis, this is y-axis. Rho is here, rho is equal to 2, and from origin to this part rho is equal to phi. And here angle, if this is r, so angle to this R, that is equal to 30 degree, and to this line your angle is 60 degree. Now find out the line integral for this path A to B, B to C, C to D, D to A. Now here this is given to you, and DL you should know, this is your cylinder. So DL for cylindrical coordinate is equal to D rho unit vector of rho plus rho d phi unit vector of phi plus dz unit vector of z. So you should know DL, then only you can find out DS. So here you have to find out closed line integral of A dot DL, that is A to B, B to C, C to D, D to A dot DL, right? Now where path L has been divided into segments AB, BC, CD, DA, as you can see in the figure, A to B, B to C, C to D, D to A. Now here first we have to find out line integral A to B. When you are finding A to B, you can see here rho is equal to 2, and DL for this, when you are considering rho, so write down here DL for rho, that is equal to rho d phi unit vector of phi. Okay, so this is the DL and this is your rho. Rho is equal to 2. Now write down here A dot DL. So A dot DL, A to B. So your angle is up to this, your angle is 60 degree at this point, and your angle is 30 degree at this point. When you are taking A to B, so 60 degree to 30 degree. Write down here limits for phi, 60 to 30 degree, and write down here rho sin phi d phi. Okay, how we can write down rho sin phi d phi? Here you can see for unit vector of rho, that is equal, unit vector of phi, that is equal to sin phi. So put the here value of rho. Now rho sin phi d phi. Now solve it by using integration, and your limits starts from 60 degree to 30 degree. So you will get this value. Now this is the line integral of A to B. Okay. Now for line integral for B to C, so again B to C, your phi is equal to 30 degree, your phi is equal to 30 degree for B to C, and DL is equal to D rho A rho, means here you can write down for rho your D rho A rho, so unit vector of rho. Now hence write down in line integral, closed line integral for this BC, or line integral for BC A dot DL. Now your rho is for B to C, so rho is 2 at this point, rho is 5 to this point. So your rho varies from 2 to 5 when you are considering the line B to C. So 2 to 5, limits write down here 2 to 5, and here write down for A rho, here rho cos phi unit vector of phi. So write down here rho cos phi in unit vector, so D rho, and calculate it by using integration method, and your limit starts from 2 to 5. So you can calculate it line integral for B to C. Now similarly you have to find out for C to D and D to A. Now here this is given, A is equal to rho cos phi unit vector of phi, rho plus sin phi unit vector of phi, and DL you should know for cylindrical coordinate. Now here you have to find out line integral for CD. Now for CD you can see CD, so here rho is equal to 5. So rho is equal to 5, so you have to find out DL with the help of this equation. Now DL is equal to, for rho d phi unit vector of phi, so write down this for phi. Now here, and close integral, line integral for C to D, that is A dot DL, and your limit starts from 30 degree to 60 degree. Now you can see your limit starts from C to D. So C to D, up to this C point your angle is 30 degree, and at this point D your angle is 60 degree. So 30 degree to 60 degree. Write down here limits 30 degree to 60 degree, and here rho sin phi, because you are considering the case of phi, So rho sin phi d phi. So from with the help of this given A, you can write down here rho sin phi d phi. Now solve it by using integration method and limit starts from 30 degree to 60 degree. You will get the answer, that is equal to 5 by 2 under root 3 minus 1. Along DA. Now the last line D to A, and write down DL with the help of this DL equation. Now DL D rho A rho. So write down this for A rho, unit vector of rho. So D rho A rho. Now here line integral find out for D to A, that is A dot DL, and when you are solving for D to A, so your rho is 5 here, and at this point A rho is 2. So rho is changing from 5 to 2 when you are considering the case of D to A. So write down here rho is equal to 5 to A, 5 to 2, and here write down the case of D rho. So D rho here rho cos phi. So from the given equation rho cos phi d rho here, and you solve it by using integration method, and your limit starts from 5 to 2, that is equal to minus 21 by 4. Now put all these values together when you are solving AB, BC, CD, DA. Now here put all these values and you will get the result 4.941. Now with the help of Stokes theorem, because line is a closed path, now here you have to use this Stokes theorem, that is left hand side closed line integral A dot dl, and right hand side you have to take curl of A dot ds. Now how to find out curl of A dot ds? Now A, it is given rho cos phi, a unit vector of rho, plus sin phi, unit vector of phi. So this is A, write out in this is the curl of A, means this is for cylindrical coordinate. Now here 1 upon rho del cross A is equal to 1 upon rho, unit vector of rho, unit vector of phi, unit vector of z. Here you have to multiply rho in unit vector of phi, del upon del rho, del upon del phi, del upon del z. As you all know, coordinates of cylindrical are in form of rho, phi and z. Right. Now here write down the value of, when you have a coordinate of rho, check in question you have rho cos phi. So put the value of A rho here, and here rho A phi. So check, is it here phi, sin phi, you can put here sin phi. Here Az is equal to 0 because there is no value for Az. Okay. So put here rho cos phi and here rho sin phi. So put all these values and find out the curl of A. Here this is del cross A is equal to A rho in bracket 1 upon rho del Az upon del phi minus del upon del z of A phi plus A phi del upon del z of A rho minus del upon del rho Az plus Az 1 upon rho del rho A phi minus del upon del phi of A rho. Now you can calculate it, you can differentiate it with respect to phi, you will get here 0. When you differentiate A phi with respect to z, you will get here 0. Now here in this bracket, when you are differentiating with respect to z or of A rho, that is equal to 0. When you are differentiating Az with respect to d rho, then you will get here 0 plus 1 upon rho. So differentiate it with respect to d rho, then you will get here this one 1 upon rho 1 plus rho sin phi Az when you are differentiating this bracket. Okay. Now this is curl of A. Curl of A is equal to 1 upon rho 1 plus rho sin phi Az. Now right hand side, first you have to find out the curl, then multiply it by ds. So ds we can find out with the help of dl is equal to d rho unit vector of rho plus rho d phi unit vector of phi plus dz unit vector of z. Now here put these values. Now you can check your theta means phi varies from 30 degree to 60 degree. So write down integration, you phi varies from 30 degree to 60 degree and rho varies from 2 to 5. So here write down 2 to 5, 1 upon rho, 1 in bracket 1 plus rho sine phi. Here this is your ds. So ds you can calculate with the help of this rho and d rho and d phi. So when you are finding ds for z, you have to multiply d rho into rho d phi, that is equal to rho d phi. So put all these values and integrate it and you will get the result same as we have done in the previous slide, that is 4.941. So this is overall for Stokes theorem. Now thank you, and you can refer this book Principles of Electromagnetics by Matthew N.O. Sadico. Thank you.